Exam 3. Problem number 3, Spring 2012. Roller coaster problem. So these obviously conservation of energy. We want to find how high the hill is. Okay, so we're given information about the speed of the roller coaster at the bottom of the hill, some losses, speed at the top. Alright, so let's draw a quick picture here. Let's draw it over here. So we're going down a hill. Here's state 1, here's state 2. Okay, here's the velocity, 20 meters per second at the top and 45 meters per second at the bottom. Okay, we want to determine the height. Okay, so pretty straightforward. We'll set our datum here at the bottom. So the final gravitational potential energy is 0, and we have a loss. 40% of initial kinetic energy. So let's see how we can factor that in. Alright, so conservation of energy says that my gravitational potential energy plus my initial kinetic energy. Okay, we have no springs, we have no work in, so we have no final gravitational potential energy. We do have a final kinetic energy and our E loss. Okay, but we're given E loss is this right here, 40% of our initial kinetic. So I'm going to rewrite that as 0.4 K0. You can calculate this K0 value and calculate a number here. This just saves me a little bit of calculation. So this is going to be H. If I move this over to the other side, I've got 0.6 times 1/2 mv0 squared is equal to 1/2 mv final squared. Okay, writing it out this way also shows that the mass will cancel out because it appears in every term on both sides of the equation. And so now I can simply solve this equation for my H. And we'll plug in my numbers and use the solver again. So we are in metric, so 9.81 meters per second squared times H is equal to Z. Oops, that should be a plus. Back up. Plus 0.6 times 1/2. V0 is 20 meters per second. 20 meters per second quantity squared. And then we'll go ahead and move this over. 45. Okay. Let's see if that works out. So in our calculator, we'll make this a little bit smaller so we can see everything. Okay. We're going to solve 9.81 times H plus 0.6 times 0.5 times 20 times 20 minus 0.5 times 45 times 45. And since I use the H variable, I have to tell it to solve for that. And we get 90.98 or 91. Okay. So that'll give us H equals 91. If we look at our units, all of these terms have meters squared over second squared, meters squared over second squared. Here we have meters over second squared, so H will be in meters. So the answer height of 91 meters.